So the title of my talk is What Your JavaScript Does When You're Not Around. This is the first talk title I've ever come up with that makes me laugh every time I say it. I always like to take a moment to picture like what my JavaScript is probably doing right now. I know it's totally this. Damn it, JavaScript. Anyway, my name is Emily Nakashima. I lead the front-end engineering team at Bugsnag. Bugsnag does exception monitoring for mobile apps for about a dozen different backend languages and frameworks, and we also do browser JavaScript. These are some of the places I've worked in the past. I really like blue logos and GitHub, apparently. And in the past, I've done full stack development, and I've even been on the pager rotation a few times. But my thing is really browser JavaScript and browser monitoring, especially the kind of work that some companies are starting to call front-end infrastructure. And I want to talk to you about a funny thing that I've watched happen in the past maybe 3 to 5 years. Kind of at the exact moment that most of my backend developer friends were figuring out how to get really good visibility into what their applications were doing in production, all of my front-end developer friends were really busy moving a lot of application logic off of the server and into JavaScript. And this is a huge part of what I'm talking about. Single-page app frameworks, especially React right now, are helping developers build the newest generation of really complex app-like browser UIs. And I think even if you're not using one of these frameworks, there's a very high likelihood that your company is writing and deploying its most complicated JavaScript ever right now. And at the same time, this code is usually running in one of the least monitored and kind of least visible parts of our application stack when our code is out in production, and that is our customers' browsers. So this really concerns me. By moving more of our application logic to the browser, we've invented all these new ways that we can leave our users staring at a blank or broken page when something goes wrong. And at most of the companies I know of, these problems won't trigger anyone getting paged or notified like a backend problem would. So I want to tell you the story of how we deployed our own new JavaScript application, and I want to talk about all the weird stuff we saw and tell you a little bit about what the process of getting better visibility looked like. So this is a project that we call Dashboard 2. Before there was Dashboard 2, there was Dashboard 1, which we released in 2013. Yeah, I know, you could have seen that one coming. Dashboard 1 did a great job of displaying application errors and metadata in a format that was simple and really easy to understand. And if you wanted to answer a basic question like, which error happened most often this week, it was really easy to see that at a glance. But if you wanted to really dive in and answer a more complicated question like, I launched a new version of my Android app, is a particular crash happening to more users who are on the current release or the prior 2 releases? That was a lot harder. So we made a bunch of architectural changes to our backend infrastructure, including adding Elasticsearch and a bunch of additional services. And the goal of all of this was to be able to enable in-depth filtering and better visualizations for our customers. And of course, we wanted to build a new UI on top that would let customers really take advantage of these features. So this is the UI that would become part of Dashboard 2. And of course, this is the part where I come in as a front-end person. I joined about 3/4 of the way into this project, which is a really interesting time to join a large rewrite. And of course, we were making all these technology changes. So we were switching to using React with Reflux in the browser, and we were doing a total rewrite of our Rails API as well. So there was like a lot of moving parts. And when I joined, there were no front-end tests at all, and there were limited back-end tests, which is always really fun as a new contributor. And so all in, with all these front-end and back-end changes, including new dependencies, we're probably going to be shipping about 30,000 to 40,000 lines of new code to production that we haven't run before. And of course, having joined late in the game, I probably have read about a couple thousand lines of code out of all that. So I don't even know what all the features are at this point. But then it's deploy time, right? So one day last fall, we did it. We just took this giant branch, we merged it to master, we did a big bang deploy. I mean, of course, we beta tested it and all that, but you know, for me, it still felt pretty momentous. And then, of course, the first thing I do is go look at our monitoring and try and figure out exactly what it is that we've just deployed. It's worth saying exactly what's in our front-end monitoring toolkit. We basically have 2 things. We measure performance. So we have StatsD and Grafana set up for our backend infrastructure. So it's possible for us to beacon timings from the browser back to the app server, and then send some of those timings to StatsD from there, just like a normal server-side timing. We also use Google Analytics, since we had that on the site at the time, and it turns out that Google Analytics will collect navigation timing or page load timing data by default. You can also send user timings there if you want to, custom timings. And of course, we also measure exceptions or errors. I think there are a handful of really good vendor products in this space right now. They mostly all kind of work the same way on the front end. You have a little bit of JavaScript that you deploy to users' browsers. A lot of times you can bundle it in with the rest of your front end code. And then that JavaScript kind of listens for uncaught exceptions. When an exception happens, it'll beacon the exception and its associated stack trace and any metadata back to the server to display in a dashboard like ours, and then possibly alert on it if you have a good product. We obviously use Bugsnag for this, since we get a really good deal on it. But like I said, there's lots of options in this space, and I should say that everything I'll talk about here you could do with most of them, or you could roll your own if you're a bigger company and you want to do that. It just takes more or less work depending on what you pick. I'm not going to talk too much about our front-end performance metrics. I think there's a lot of really good drop-in libraries and vendor tools out there that'll collect these for you. And I think our stats here were pretty much what we'd expected. We knew that our JavaScript and CSS were going to get a little bit bigger, and so we knew that page load performance was going to go up a little bit. And I should also say that we're a fairly young startup, a fairly small company, so we don't have massive traffic, so our front-end page load times can be pretty volatile, and it can be tricky to derive useful data from them unless something really big changes. So we keep an eye on them, but not the most important part for us. Our browser exception monitoring is a totally different story. We get a lot of data there, and some of it is super helpful, and some of it is a little unexpected and hard to parse. So I want to talk through some of the most surprising cases because I think they illuminate some of the bigger issues in front-end monitoring right now. Here's a good example of the stuff that comes in that makes complete sense. We deployed a small behavior change to one of the main graphs on our site, and all of a sudden we start seeing this error that's kind of happening constantly at a low volume. The error is reference error. This.drawTimeline is undefined. And of course, if we look at the stack trace, we can see it pointing back to one of our own JavaScript components. So it's really easy to dig into this kind of error. This is exactly what you want to see. There's a function with a unique name. We can follow the stack trace through our own code to figure out what's going on. And in this case, we can see right away that we just moved a function from one scope to another, and we just need to go change the invocation. But everywhere I've worked that we've done JavaScript exception monitoring, only about 20 to 40% of our new JS errors are going to fall into this category. The rest are usually much harder to make sense of. So much more often you'll see stuff like this. The exception class is NS error XPC security manager veto. This is not a common error class that I see a lot in the browser, right? The stack trace isn't coming from my code, it's coming from someplace called top level, and I see it's happened dozens of times, but I can see in our tool that it's only happened to one user. So what's happening here? Of course, professional front-end developer, I go Google this string immediately. So I find a bunch of forums with people saying, like, I just wrote this Firefox extension, it doesn't work, it keeps throwing this error in a loop. Don't even have to read any further. I know exactly what's going on here. Our code is fine, someone just installed this like crappy browser extension, and it's totally broken and just like throwing errors all the time. Bugsnag luckily filters out most errors from extensions by default, but if you're rolling your own monitoring, you'll definitely want to have handling for this case. When I was at GitHub, we used to roll our own, and we would add code at the point of collection to filter out browser extension errors by looking at the stack trace. And every time we investigated an error, if we found the root cause and we saw that it was some third party, we'd immediately add code to ignore it with a little comment documenting exactly what it was. I think before we made those changes, it was probably that like more than half of our browser JavaScript errors coming in on any given day would be from extensions. And of course, like that's someone else's code. There's no way we can fix it. It's not actionable, so it's our highest priority to go tune it out. In the good exception monitoring products now, there's usually a button for this, like ours is called ignore, and we make really heavy use of that to keep our data actionable. So what is my JavaScript doing out there in customers' browsers when I'm not around? Number one, most important, it's hanging out in a very noisy room. We use Gulp and Webpack to package up all of our JavaScript and CSS into just 3 files. And it's really easy to kind of fool ourselves into believing that that's the sum total of what's running in a user's browser at a given time. But our monitoring is constantly telling us that that's not true. For example, there's this JavaScript error that we suddenly saw start spiking out of nowhere. It's hard to tell exactly what the magnitude is, but that's like thousands of errors all at once. And the error is cannot find module bind all. And we see from the stack trace that it's coming from a third-party CDN. So this is an analytics vendor that we work with. They just push some bad code to production, and they're experiencing what is effectively an outage. Like their infrastructure is fine, but they've deployed this bad code, and all of a sudden, they're throwing an error. So the cool thing for us is we actually found out about this a few minutes before it went up on their status page. We get a Slack notification every time a new error happens on our site. And so if we needed to, we could have taken action right away and redeployed a version of the site without this code in it. This one was a wake-up call for us to get rid of some of the callbacks that assume this vendor code will always run, which we had. Took those out. But I want to say it's really hard to actually overestimate the magnitude of this like third-party code problem on some sites. If you have advertising or remarketing tags, they often load other scripts. Sometimes they load different ones for different users, so you can't even test locally to see which ones they are. This graphic shows data from Ghostery, which has an enterprise product that will give you really cool visibility into this stuff. And this is a report of all the third-party code that can load on tmz.com. So if you look out to the far, far right, those are tags that are loaded by tags that are loaded by other tags. So it goes like many layers deep. So all totaled, TMZ can load 539 possible tags from a total of 68 different unique vendors who all have access to your client-side data, but that's a different talk. So if you allow these third parties on your site, all of this code can be running in the browser with your code, and there's lots of space for things to go wrong there. I mean, this is a bit of a pathological case, but the average e-commerce site or media site usually doesn't look too far off from this. And of course, the flip side of this is that a large number of our users have ad blockers installed for good reasons. No surprise there, but sometimes they block some things you wouldn't think of as ad scripts. So we know that pretty much any third party, including your analytics provider, including us, including any other kind of exception monitoring or browser monitoring, could be blocked at any time. So the one thing for us that's been the most helpful here is to migrate to using Webpack, which moves more of our code out of the global scope and makes us be much more explicit about referencing external globals. And this means that when third parties do weird stuff like throw errors or inject new versions of dependencies into the page, which they do, some dependencies, like they inject their own version of jQuery, like why are you doing that? We tend to be a little more sheltered from that fallout when it happens because of how we're packaging up our code. So number two, our code doesn't always run where we think it runs. It has a tendency to go wander off to someplace or another. This is one of the joys of working on the front end where your code is just public. This is one of the weirdest lessons for me. We deploy our code to bugsnag.com, which points to some Amazon servers in the cloud. We think of our code as always running at the bugsnag.com domain in production, but sometimes we would see other domains pop up in our monitoring. These are proxy sites. One of the most common proxy sites out there is actually Google Translate. Google can serve your code from the translate.google.com domain. So this is our marketing site translated into Portuguese. And this is cool. This is actually a pretty legitimate use case for us. We want people to have this content available. There's another case like this that's worth considering, which is proxy sites that help people get around firewalls. One notable one is Grapefire. They have projects that help internet users get around Great Firewall restrictions by mirroring blocked political or news sites in mainland China. And depending on what kind of information you host, it might be important to you to make sure that your site still works in scenarios like this. So if you want to support these, you typically don't have to do too much to handle the use case since the proxy or the mirror is usually pretty smart about rewriting requests. But the one big reminder for us was don't write JavaScript where you check the host name to mean, is this production? If you don't want to support these, do the reverse. Like you can write code that throws an error if it shows up someplace else and then reports back to your monitoring, but it's worth thinking about either way. Number three, network problems are always, I'm sure I don't have to tell this room that, you know. Sometimes our JavaScript just doesn't get there, it doesn't show up. We know from our stats that we have plenty of customers on airplanes or on DSL or in New Zealand, and they're having, they're having quite a different experience than we are in the office, and it's really easy to forget that. This is especially important now that we're using a JavaScript framework like React. It's really easy to create complex request dependencies by mistake. So all of the gold boxes here show UI components that have the ability to trigger a data request. And of course, in React, it's really common to nest components inside other components. So it becomes really easy to inadvertently trigger sequential requests as you embed components. So for us, we're too small to do a lot of engineering at the network level to try and make requests faster. But we do want good visibility when problems like this start to happen. So here's an example. We're seeing reference error, jQuery is not defined, and it's sort of happening sporadically to many users. No real pattern. When you look at how we're loading this code, there's that jQuery script that loads first, synchronously, and then you look at that second script, and that's the one that's actually throwing the error. So from the code, it's pretty clear that what's happening is that that first script is either just timing out or it failed to load in some way. We know that whenever teammates see this error, it takes them a second to figure out what's going on here. So the nice thing for us to do is to add an explicit check for jQuery as the first line of that second script, and then throw an error with a more informative message so our teammates know exactly what happened. So we can change this and just have it immediately throw an error that says like, warning, jQuery.js script failed to load. That way our whole team knows what's happening right away, and people don't have to always invest that 5 minutes to figure out like, what happened here? So for us, there's not a whole lot we can do if an entire asset file fails to load. If we had more bandwidth, if we were kind of a bigger team, we could look at setting up Service Worker or something like that in the browser so that we could have offline support and kind of fine-tune how we're using the browser cache. But for a small team like us, the biggest thing we can do is try to be smarter about when we make data requests and try to move them earlier in the page load. The one big behavior change for us was to start using a network simulation tool to look at failure states and look at slow request states. So it's definitely worth firing up your site and testing on like a 3G or like a slow DSL connection and look at offline conditions as well. And then it'll be pretty easy to spot issues like requests that are daisy chained together, and it'll help you get familiar with what kinds of error messages you'll see in failure states so that you can recognize these when they pop up in your tools and maybe replace them with an error message that's more informative. This right here this is the Chrome dev tools, so you don't even have to go download Charles Proxy or anything anymore. You can just play with this right in your browser, which is great. And finally, we saw that our app isn't always used the way that we like to think it's used. This is a really fun one. This is my favorite JavaScript error of all time. The exception class is waking up dev, thank you. And the imp emoji is definitely not a custom error message we have in our code base. So what's happening here? This is developers. Developers tend to run a lot of code in the browser DevTools console. So this is just some developer throwing an error to troll us. Thanks, I appreciated it. But sometimes we can actually get useful data by seeing what developers are console hacking on our site. For example, one time I saw someone trying to traverse the DOM to get to some text that was in there, kind of deeply nested. We had API keys on this page in our UI, but we had accidentally disabled the CSS that would enable text selection. So watching the errors coming out of the console, I could see that this user was like trying very carefully to get to this data, probably to be able to copy paste it more easily. So that helped us spot a CSS change that we needed to make to our UI. If you have a lot of developers as customers, if you're blessed with that, you'll get to know this browser dev tool stack trace really well in your monitoring. In Chrome, look for file anonymous and then object injected script in the call stack. And I think in particular you can learn from watching developers who want to try to hack you. So this is a really small subset of our user accounts that match the letters XSS. And of course, these are all developers trying to hack us. No one has cleverly named their company that. The great part is that these users almost always tend to throw a lot of exceptions as they're kind of poking around at the site. So it's kind of fun for me to keep an eye on their accounts and make sure that I'm thinking about security for all the same cases that they're considering. For example, this admin drop-down menu actually used to have an XSS vulnerability, and it would not render if you tried to run this search. Luckily, we set very restrictive content security policy headers, so nobody actually had to like click and dismiss the alert in shame. But our exception monitoring did help us find and fix this. So that was a dive into some of the funniest things we saw in our JavaScript exception monitoring after our big rollout, kind of out of the box. And from what we learned there, we were able to kind of know enough to start adding some custom front-end metrics. Remember how I said we had these two browser monitoring tools? It turns out that it's very easy to push custom data to these as well versus the stuff that they're just collecting by default. So the top call is a simplified version of the JavaScript that it would take to push custom timings to our stats endpoint, and the bottom call is what it would take to push a custom event to our exception monitoring. Call it an event instead of an exception, same thing. So we've started to transition from thinking about these tools as like a performance tool and an errors tool, and then we can think about them more as a metrics tool and an events tool, a little more generic. Anything we primarily want to see on a time series graph or as a count or a gauge, we'll send to StatsD or Google Analytics. And anything we want to look at individually with metadata in addition to seeing it graphed, we'll send to Bugsnag. And we've found plenty of these things that are not strictly errors, but that we still want to capture. For Bugsnag, we now set a level property on all of our events, and we set it to either error, warning, or info, as opposed to just assuming everything is an error by default. So one good example here, we know that a common problem that people have with single-page apps is that they don't trust the data the app is currently displaying on screen. They've been clicking around a little bit, going from page to page, and all of a sudden the UI looks weird, or it's like not doing the right thing when you click. I think we've all sort of like lived with these JavaScript web applications enough to know to try to like refresh to fix it. So we kind of wanted to understand the circumstances where people just didn't trust our applications and were choosing to refresh. So we started doing refresh tracking. Christian, who's a JavaScript developer on my team, set this up. It's really cool. Whenever someone presses Command R or Control R in the browser, we log that as an event with level info. And we can look at the pages where users refresh the most and get a sense for what pages we have where users don't trust our app. Not super surprisingly, we saw that the two highest pages were the pages where we have the complex graphs. People look at some weird spike that's in there and they're like, did that really happen? But we also noticed, and this one was a big surprise, that this is not one of our most popular pages, but we noticed that people refresh a lot on the collaborators view in our settings. So we think that the use case is that people are adding teammates and they want to see if their teammate got in and could start using the app right away. And so this was a lesson to us to maybe think about adding live updates or something like that to our settings to be able to handle this use case. One particular aspect of UX that I would love to do more monitoring of is accessibility. It's really early days for bug snag accessibility. We're not great at this yet. But, and I should say that there are tools that you can run as part of your test suite that will check for accessibility problems, but I think that these tools never capture kind of the variety in your production data or the full range of pages on your site. People usually just test a couple of main pages. So I like to check it live. This is a really simple example. You just comb the DOM, you look for any images that don't have an alt attribute, and then you report the results back as an event, and you send the source so you can go find that image and replace it. You could do this for any DOM condition you know presents an accessibility issue, like form elements that don't have a label, or labels that don't have a form element. Those are both problems. And credit to some former GitHub coworkers of mine, Josh Peek and Juan, who worked on this technique. I would love to do more of this in the future. It's really cool. And finally, we found that there's a lot of room for more complex types of performance monitoring beyond typical page load timing and resource loading stats, especially if you have a single page app. I've spoken in the past on collecting timings for AJAX requests and for push state navigations. You absolutely should do that. But I'm experimenting with something a little more fun in this department, which is memory leak monitoring. A lot of these JavaScript single page app frameworks, it's really easy to hold references to nodes and have a memory leak. And for some parts of our site that are a single page app, users can navigate around from page to page for a long time without ever actually forcing a hard browser reload. So what we're doing is we're looking at the used JavaScript heap size after each navigation and seeing if it only gets worse or if it sometimes gets better. This is just a super quick sketch. Chrome exposes this window performance memory used JS heap size attribute. The number itself isn't very meaningful or granular for security reasons, but if you check it as you navigate around the site and you see that it continually keeps stepping upward, then you know that you might have a problem. Like I said, this is just an experiment. I'll have to write a blog post if I get any useful data out of it. And that was just a little taste of what you could monitor in the browser, but there's so much other data that you could get curious about. Basically, anything that you can check with JavaScript, you could collect data about and beacon back to the server. I mean, you don't want to like log keystrokes and that kind of thing, but there's a lot of options here. So you can derive geographical location. You can check installed fonts to see if you want to switch your design to use a system font that most of your users have. You can log screen dimensions and color depth to try and optimize your design to a particular screen size. Browser language, online, offline status, battery level and charging status, which is a little creepy when you think about it. Emoji support, page visibility, connection type, and then support for emerging browser APIs. So if you want to know, can I work with an API yet, you can do a check to see if it's available, and then you can log that somewhere. When all your users get to a certain point, you know you can deploy code that uses it. And there's so much other data that we can get curious about. Some of these, I should say, are in the browser now. Some of them are like drafts. They might be coming soon. But I think all of these could potentially be interesting to you, depending on what you want to build next in your app. So that was a lot of browser monitoring. What does it all mean, especially for this room where I know a lot of you are not front-end developers? For one, I think browser monitoring is ready now. A lot of people have the perception that it's too noisy or that the tools aren't there. They're there. They just need to be tuned. I think it's just like any other monitoring tool where there's a learning curve and you have to figure out how to make sense out of the noise. I think monitoring performance is not enough, especially if your team is using a complicated framework like React or Angular or Ember. It's doing a lot more than just loading onto the page. You should be monitoring more than that, like performance, exceptions, security, and other aspects of the user experience that are important to your site are all things to think about monitoring. I think the corollary to having all this monitoring is that front-end developers really can get paged now, which I'm really sorry if you're in this room and you're a front-end developer. I think this doesn't necessarily mean having your own PagerDuty rotation for front-end, but there are definitely channels where I, as a front-end developer, want to get pushed alerts about my code. Chat is my favorite. We use Slack, and so we can push alerts to a front-end room, and then I can configure push notifications depending on what's in that alert. So I think front-end developers should get alerts for at least 2 cases. One, when there's a spike of browser JavaScript errors that are happening to many different users at once. You definitely don't want to alert if just one user is getting 1,000 exceptions, because that's just something weird happening to that one person. But many different users at once, I want to get notified. And 2, if front-end load timings start going up, but back-end timings aren't, that's something I want to know about as well. So I'm sure in this crowd you can see the appeal in kind of having your whole team work with alerts and be on the hook to respond to production issues. I think it really does wonders for helping your team develop empathy toward folks who are on the pager rotation and help everyone better understand how to write production-grade software. I also think that testing everything everywhere is dead. Many browsers now roll out a new version every few months, and they're kind of getting better and better about building them to match the specs. Yay, that's great. And I think there are just too many browser versions out there for our team to fire up a browser stack or something like that and try every version now. On the flip side, this means that I can finally kind of give up the dream of fixing those crappy Selenium tests that were always read in 2 or 3 browsers that just sort of plague you and you like turn the monitor around and not have to look at it. Those are gone, those are dead to me. Especially with single page apps where data can carry over from one page to the next. If you think of your app as kind of a state machine, like all of a sudden you can create really infinite complexity there. You definitely won't be able to test every state. So we still do unit tests, and for our browser JavaScript notifier, we still want to do multi-browser tests, but we definitely don't need them for everything anymore. We get a lot more information from our monitoring. It tends to be much more actionable. This one is probably the most important for this room, which is that the monitoring team doesn't know what the JavaScript does. There's usually a team that's responsible for the monitoring, and that team usually sits far away from the JS team. That team may still be under the assumption that a state where users are seeing a bunch of broken stuff will map to a spike in 500 errors or some other non-200 status. That may not be the case anymore if your team's doing a single page app or something that's very JavaScript heavy. It's definitely worth trying to bring these 2 teams together and talk about what JavaScript failure cases can look like and find out if both teams agree that you're monitoring the right things. So I think this is all particularly relevant now that the pendulum is hopefully kind of swinging back a little bit from the native app side. People are talking about progressive web apps as kind of the new thing. And they're back again, I know. It's like responsive design all over again. I think, recently, even with longer release cycles, mobile app developers have been so much better at using monitoring to find and fix crashes quickly. And I think if we really want people to take browser applications seriously as an alternative to native apps, and I think we really do, because I think for most of our engineering teams, it actually means a lot less work overall. But we need to reach that same level of reliability. And I think that better browser monitoring is a huge part of how we'll do that. Thank you. If you want to talk about this stuff, please come find me out there. It's my favorite topic ever, and there's not that many front-end people who are into monitoring, so come talk to me. Thank you.